that keeps us alive is killing us.
Massive chemical fire in Texas. Well, the blaze has gone out, but the air quality...
9 daripada 10 penduduk dunia menghirup udara yang tercemar melebihi tahap yang
When will we be able to breathe easy?
Urban outdoor air pollution refers to the air pollution experienced by populations living in and around urban areas, for example, cities. It is estimated to cause about 2 million premature deaths worldwide annually. Moreover, urban air pollution is still increasing in major cities, particularly developing countries.
Particulate matter (PM) is the biggest source of air pollution. Traffic transportation is the biggest source of air pollution, contributing 1/4 of PM in the air. Others factors that lead to urban air pollution including forest fire, slash and burn, mining and quarrying, agriculture. Traffic is the highest contribution factors for particulate matters. Here are the problems of air quality in Klang Valley. Multiple sources of information, a range of scales in space and time from street canyons to metropolitan areas, from short-term episodes to annual averages. Distributed emission sources, direct regulatory and economic control on emission sources. Multiple objectives and criteria for different actors and regulatory framework. In 2009, only 5% of the days showed unhealthy API level. Unhealthy days due to high traffic volumes led to formation of ground-level ozone. Dry spell, El Niño, is one of the contributing factors. Acid rain in Klang Valley showed monitored rainwater pH ranging from 4.4 to 4.8. So, what are the contributing factors of air pollution in Klang Valley? Urbanization due to drastic development and change in land use. High concentration of PM10 from industry units and urban areas. Increase the burning of fossil fuel from vehicles. Increase the demand for cars and vehicles due to urbanization. Large number of vehicles, poor conditions of roads and inefficiency of public transport led to the traffic congestion in the main cities. Economic growth and high demands of commodities rose the manufacturing and processing industries. Forest fires in neighboring countries also contributes high concentration of pollutants.
The study was conducted in Kuala Lumpur City, Malaysia. The total land area of the city is 243.7 square kilometers, 24,221.05 hectare, which is 100% urban area. It had a population of 1,556,200 people in year 2005 with an average population density of 64 persons per hectare. The monitoring station of KL was located at Victoria Secondary School, in city centre, in year 2003 and before. However, the monitoring station has been moved to Sri Permaisuri, which is located outside from city centre from year 2004 onwards. Relationship between air quality and urban growth. Air quality trend in Kuala Lumpur. The ability of the urban ecosystem to purify the air. The urban growth. The relationship between air quality and other urban parameters such as total population and average traf-C volume were not significant even at the 0.1 level in both time series and zone level study. It can be explained with the argument that air pollution in KL is not only generated by residents, the population, only but also visitors and users who are working, studying or consuming in KL. The traf-C sampling stations were not distributed equally in KL city. Therefore, it might neither represent general traf-C condition in KL nor traf-C condition at the air quality sampling station.
Air Pollutants Index (API) is a simple and generalized way to describe the air quality used in Malaysia. There are 5 levels of atmospheric pollutants that affecting API, which are sulfur dioxide, nitrogen oxide, carbon monoxide, particulate matter and ozone. Therefore, the pollutants released in urban will also affect the overall API. To determine the API for a given time period, the sub-index values for all 5 air pollutants included in the API system were calculated based on the average concentration calculated. The maximum sub-index of all 5 pollutants was selected as the API, and the specific responsible air pollutants for the API value has to be reported to indicate the relevant health effect category and actions to be taken. The following figure shows the air quality index indicator. About 99% of the sulfur dioxide in air comes from human sources. The main source of sulfur dioxide in the air is industrial activity that processes materials that contain sulfur, such as the generation of electricity from coal, oil or gas that contains sulfur. Some mineral ores also contain sulfur, and sulfur dioxide is released when they are processed. In addition, industrial activities that burn fossil fuels containing sulfur can be important sources of sulfur dioxide. Sulfur dioxide is also present in motor vehicle emissions, as the result of fuel combustion. In the presence of very high temperatures, nitrogen and oxygen do react together to form nitric oxide. These conditions are found in the combustion of coal and oil at electric power plants, and also during the combustion of gasoline in automobiles. Both of these sources contribute about equally to the formation of nitrogen oxides. In areas of high automobile traffic, such as in large cities, the amount of nitrogen oxides emitted into the atmosphere can be quite significant. The largest anthropogenic source of CO is vehicle emissions. Primary PM sources are derived from both human and natural activities. These types of activities include agricultural operations, industrial processes, combustion of wood and fossil fuels, construction and demolition activities, and entrainment of road dust into the air. Natural, non-anthropogenic or biogenic sources also contribute to the overall PM problem. Secondary PM sources directly emit air contaminants into the atmosphere that form or help form PM. Hence, these pollutants are considered precursors to PM formation. And lastly, ground-level ozone, a secondary pollutant which is produced when 2 primary pollutants react in sunlight and stagnant air. The pollutant components are calculated in ppm while PM10 are calculated in microgram per meter cube. The data are updated hourly. The air monitoring station at Technical High School MUAR shows that the highest value of API reading with 663 on the 23rd of June 2013, which was on emergency level. It is where Malaysia faced the worst air quality due to haze episodes. API value reading is important for determining the level of air quality. Poor quality of air can bring about harmful effects on human health, the environment, and also economic development.
I'm afraid that time has come and gone, my friend.
What can we do?
Save as many as you can.